Hi guys, welcome to Learn Electronics Repair. And there's a bit of a story to this one. So it's strange how life revolves in a way. I had an email off a subscriber not long ago actually, and he said, oh, he's got a shop. He's somewhere in Asia, I seem to remember. He's got a shop and he got a lot of faulty SSD drives and said, can you make a video how to repair SSD drives? And I said, well, I don't have any experience with that, but I guess it's electronics. But if I ever do get a job and repair an SSD, I'll have a go and yeah, let's make a video. And then lo and behold, what turns up? An SSD. So this is a 4 terabyte SSD drive. Obviously this is like the contents out of the Sata drive. And this came in via Handy Andy through Detleft's hands. So basically, Handy Andy says a customer had 2 of these, but he didn't buy them from Andy. I will say, I thought they were from Andy, they're not. A customer got 2 of these from somewhere, and after some time they both packed up, and he came down to Handy Andy and said, can you repair them? And apparently Andy said, no, because you've bought crap. You bought crap, so it's your own fault. Whether that's true, I don't know. I don't know what this comes out of. It says on the back of it, let's see. Yeah, some numbers there. There's 2 spaces for chips here, so we can see what's under the RAM chips, like the BGA. Apparently, this comes in a 4 or 8 terabyte version. This is the 4 terabyte version. It may just be that Handy Andy said, well, you've bought crap from somewhere, so it's nothing, you know, I'm having anything to do with. It might just be to say, well, you didn't buy them from me, so sod off. Yeah, okay. But anyway, however about, the customer still has 1 of them, and I have the other one. Detlef said, can you fix it? So let's have a look. So basically, there isn't a lot on here, yeah? We have a controller chip of some sort. The markings are completely obliterated on that, completely ground off. We're not going to be able to read that. I would say they've made quite a good job of it. We have 2 chips marked 29FSR-HB3 and some more letters. I've had a look for a data sheet but couldn't find anything for these. This is an EPROM, so I'm sure that's an EPROM. P35T22H. I'm fairly sure that's an EPROM. As to what it stores, don't really know. I can't imagine it stores a program because let's face it, this thing is like a controller, like a GPU. It might be like a BIOS. So a GPU, for example, will have a BIOS because it effectively has no static memory on the graphics card, therefore when it powers up it doesn't know what it is. But that's not the case here because obviously there's memory here, so this can store some parameters in here and it wouldn't take much space. So whether it does that, I don't know. Whether this is kind of like bad sectors or something, I don't know. So there's some don't knows, but there are some I do knows. So we see here 3 of these chips, 6 pins each. Each one has an inductor by it, so we can say we have 3 voltage regulators here with 3 different outputs. We have a 0 ohm resistor here which could act like a fuse. We have another one, and that's what we've got. So can we form any sort of strategy to repair this? Well, the first thing I would say is it's possible these are fake in some way, and that's why they've both failed. I don't know all of the story, only what Handy Andy told us. So possibly they are just fake, filled up. Well, you think if a drive filled up, you could kind of format it and you could store it again up to its actual capacity. Yeah, which is probably less than what it claims to be. That's one possibility. Another possibility is one of the supply rails has failed. Or something like that, so it doesn't get power. Could be a problem with the contents of this EPROM, but probably not easy to test that. But what we could do is have a look to see on the chip select on this, especially if we can find a data sheet, but it's probably pin 1. We can see whether that is being accessed. Maybe that will give us some clue as to whether this is doing anything. We have a crystal here, 25 megahertz, so we can test to see if that's running. And if all those things are okay, or as okay as we can say, I mean, we can unsolder this and have a look to see what's inside it. Again, I'm not sure how useful that would be, but we could. It would at least tell us if the EPROM's okay. Electrically okay, I don't mean content's okay. We could try unsoldering these and resoldering them. So there's not so many balls in the array there. That wouldn't be too difficult to do by hand, I don't think. So that's another possibility. And thinking about it, we can measure how much current this draws when it powers up. This controller obviously talks to the Sata. So there will be communication lanes. I've never really looked into SATA, but I'm guessing LVDS, similar to like PCIe or USB. And we can probably, from the data pins in diode mode, measure to ground. And if they all look the same, then we can probably say the input circuitry to this chip is okay. So that's another thing we can do. We can get the thermal camera and see if anything is warm or cold, or these two the same temperature. That might tell us something. So I think we do have a formula for working on this. Whether or not it will actually come to a repair is anybody's guess. You what? Get guessing. So I'm going to power this up and let's see if all the voltage rails are there and how much current it draws. Of course, there is more than one way of doing this. So one option would be to connect this to a bench power supply, power it up. We have a 5 and a 12. I suspect it probably only uses one of those in actual fact. In fact, we can prove that during this video. So you could do that, power it up that way, and then the bench power supply will tell you how much current this is drawing. The other option would to be used my clamp meter, and I think this is probably just the easier way for me. So let's power it up. I'll clip this around the ground leads, and then whatever current combined is flowing through those, they should register. I'll select DC amps. That's reading down to a milliamp. Okay, that's fine. Right, let's power this up. And what do we have? 154 milliamps. It wasn't quite zeroed. I actually have a 0 button on. Okay, try again. 130 milliamps. That's what it's drawing. So it's drawing a little bit of power. Out of interest now, because of what this video is just going to be out of interest, I think. Let's learn a bit. So we'll go to the red wire, the 5 volts. Power it up. What's on that one? Well, that's saying interestingly negative. Switch it off. 135 milliamps, that's saying negative. If one can have such a thing as negative amps. Okay, what about the yellow one? Nothing. So if you did wonder, all the power comes down the red wire. Okay, so we know what it's drawing. Let's have a look for the voltages. Let's see what we have. What do we see? So this should be the 12. 4.8 it says. Red one. Yeah, meter's working. 4.65. Okay, so the meter works. What do you have on these coils now? 1.1. Okay, so 1.1, that looks about right for the processor thing. Nothing getting particularly hot, but it's not a lot of current. This one, 1.8. That looks right for RAM to me, for memory. 1.8. This one, oh, the BIOS could run on that 1.8, by the way. 3.3. So you have 5 volts coming in, 3.3, 1.8, 1.1. Power to the BIOS should be on that pin, I think, if this is the right way round for the chip. Let's have a look. Yeah, there's pin 1. Okay, so this is almost certainly the BIOS power on this one. 3.3, so it's a 3.3 volt BIOS, quite possibly 1.8 volt memory supply, and then 1.1 for the processor. So the voltages look okay as far as I can tell. Right, let's get a thermal camera. Okay, so that is the, I'm guessing we can call it a processor, that chip. Just getting nicely into focus. Okay, so that is temperature point, it's about 50 degrees. Okay, this is the oscillator, which is just cold, 33, well, relatively cold. I mean, the workshop's probably 30 degrees. BIOS 42, and then the RAM chips 39. Can we see both of them? That's one. The other one's kind of like slid on the edge of my phone a little bit. It's there. Okay, so they're about the same as each other. So the only thing that's drawing any power from what I can see is the processor, but it's not overly hot, I would say. I've attached the hard drive to my test motherboard plus my little 60 gigabyte boot drive that I use. So we can see the BIOS is not detecting that drive. It just isn't there, basically. So when the owner says it's screwed up, I think it means more like it's disappeared. Yeah. Let's see if the oscillator is running. So I find my analog scope easiest for this sort of thing, to be quite honest. We can see straight away if it's running or not. Something's happening. Oh yeah, it's running all right. Even if I can't see the waveform very clearly, that's not really important. I just know it's running. Yeah, oscillator is running, so that seems to be okay. Is it really running at 25 megahertz? Well, that scope won't actually tell me. The other one will, so we can try it, but I don't think really oscillators fail in that way. It either oscillates or it don't. Yeah, but for those who are saying, let's try the digital scope, see if it's more or less difficult or easy or makes any difference to using the analog one. I have ×10 probe. I've turned the sensitivity up as far as it will go. I definitely have a good connection there. I have the ground plugged in, so let's see if we can see the oscillations on this as clearly. Okay, so crystal, there we have it. It says 25 megahertz. Okay, maybe it's just me likes the old analog scope. That did at least as good a job, actually better, so maybe I'll say no more about that. You guys can talk about it down there. Okay, but either way we can see the oscillator is running. I'm not sure at which point it would actually access the BIOS, or even if this is the right pin. Let's have a look. So it has about 2.7, 2.8 volts on. Let's switch the power supply off. Okay, you saw something there. Switch on, and it just goes high and stays high. That's pin 1. Okay, let's see if we can find a data sheet for this chip, just to make sure that really is the access pin. Yeah, the chip select. Well, AI, or as they call it here, IA, tells me that in SSDs the EPROM is used to store essential firmware and configuration data such as the boot code, which is needed to initialize the drive when the system powers on. So if the controller never reads the EPROM, yeah, it can't initialize the drive. It can't reply to the computer. Now, you might think, and we'll prove this, because I'm sure it'll make no difference, that the drive only initializes when the motherboard kind of with the Sata signal says initialize, yeah? But that isn't the case. Hard drives initialize when you first power them on, so we should see activity there, and we don't. The actual EPROM is this one, P25T22H, and we can see that pin 1 is in fact the chip select, so hash sign means active low, so we should see negative going pulses on there when the drive initializes, and we're not doing. And this should occur before the processor is trying to access the data, the RAM, yeah, the hard drive. So you can see here, this is your SATA connector. If you look up the pin out for SATA, you'll find it has two LVDS lanes, low voltage differential signal. This is the same way that PCIe works, that HDMI works, and pretty much anything really these days that's transmitting data. So on the actual SATA connector, there are two data lanes here, these two pins, plus and minus, these two, plus and minus. The data is effectively an AC signal, and the way that the differential signal works is rather than sending like a series of pulses, yeah, to carry data, it switches backwards and forwards which one is the positive relative to the other one, and that means that any noise on the cable will affect both simultaneously. So although interference will add voltage to this, it won't affect which one is more positive than the other. They kind of like float around together, and you're switching backwards and forwards, the plus and minus to carry data. And we have two lanes there and there, okay? Those will go into the controller chip, so that's how it talks to the computer. And there'll be some capacitors, we can see them here, there. This is the same with the graphics card, the same with the motherboard. For example, by the PCIe slot, you can see capacitors. With a PCIe slot, by the way, the capacitors are only on one side, one set of lanes, and on the other side, the capacitors on the device plugged in. That's why, for example, your graphics card only has capacitors on one side. So effectively the capacitors are half on the host and half on the supported device, okay? So let's have a look at what we have here. We need to reference to ground, so I'll connect my black meter lead to ground. I'm on diode mode, okay? And if we look from here, it says open. That open, yeah, open. That's because of the capacitors. So if you look, you'll see that the other side of the capacitor goes to the chip, yeah. So this one reads 0.89. You can't say exactly what they should read because they will vary a little bit depending on the type of controller, but what you can say is all of the lanes should be the same or close. 0.88, 0.88. So that's fine. If you had one of these reading open or short or vastly different from the other ones, that means you have a fault in the chip. Another thing we can just check, and I'll just prove this to you. So this is where the lane comes in. That'll go to one of these capacitors, this one, okay, other lane, that one, and then the same on this side, here, and if we just check between the positive and negative LVDS signal, they should not be shorted to each other, okay, and it just has a reading. This one has a reading, so they're not shorted to each other, so I'd say they look okay. So the communication on the SATA cable should be okay, but the problem seems to occur before it gets that far anyway. Let's just connect this back to the motherboard and we'll boot it and we'll look again to see if we can see any activity on pin 1 here. But I'm confident enough that we won't do. Okay, so I'm on pin 1 of the chip here. Let's power this up and let's see if anything happens. And nothing happens, okay? It just goes, oh, you know what? Something is happening. We do see something there. Let me just change the time base actually. Possibly it was there before. I was just didn't have it on here for long enough. I either have a bad connection on here or we are seeing something. Let me just make sure I get a good connection onto the chip. Let's try that again. So I'll try and trigger the scope on this time. Just get onto the chip. Set the trigger point somewhere there. Okay. So once the waveform or the voltage goes above that point, it should trigger. Ready? There. Okay. And we can see we definitely have activity. So in actual fact, this is trying to read the BIOS or reading something from the BIOS. Okay, just try that again with a different time base setting. It triggered and then re-triggered on another drop there, okay, but you did see there was definitely some data access and then one more when it triggered the second time, which is what we can see there. So yeah, that is trying to read the BIOS. Let's try that again without the SATA cable. I'm interested to see if it only reads the BIOS when the SATA is attached. Yeah, for educational purposes. Okay, so let's have a look. So back onto here, back into normal mode, set a trigger level. Okay, yeah, so certainly it is actually trying to read the BIOS, and it does that whether the SATA cable is attached or not. So I'd say the controller is probably working. It just maybe just doesn't like something in there, and that's probably something I certainly don't have the knowledge to do anything about. But what we can do is let's have a look to see what's inside that chip out of interest. I've unsoldered the EPROM. Now this particular chip, P22T25H, is not on the list of supported devices in my programming. So I went onto Google and searched for an equivalent to that chip, and I found some equivalents. So I put one of those equivalents in here, which is W25X20AL. Okay, same package. And if I try to read the chip like so, it will tell me that the check ID is wrong because it's a different type of chip. But I do actually have an option to switch that off. So to tell it to ignore the ID check, we cancel this, we remove the tick for check ID, and we tell it to read it again, and now it will just attempt to read it. And you can see it's reading the chip, okay? And we have some contents. Now, you can't see anything particularly in here to think, well, did it read the chip properly or not? But if you just scroll down quite a way, there, you see I just went past it here. So there's loads of text here, like you see, unknown, GUL, whatever, parity, polling task. We can read things here, unknown flash feature, fail to load default parameter, and so on. So there are messages in here, text, and because it reads the text from the EPROM, we can assume that it's reading the EPROM correctly, including the code, okay? So I can read the EPROM, and that tells me the EPROM itself is okay. It doesn't tell me whether or not the contents are okay, but it tells me that the EPROM is okay. I'll save that. SSD, EPROM we'll call it, and save it. Okay, so I actually have a copy of that. I can stick the chip back on there because I don't have anything to actually program this with, and anyway, it may well have data in it which is actually specific to this drive. So where does that leave us? Well, we have the controller chip, which we don't know what it is. This is a QFN by the looks of it, so I could get flux around that, warm it up somewhat, use my soldering iron and sort of drag solder around it, and that presumably would stop any problems caused by bad connections. The same with the BGA chips, to be quite honest, because if we turn it over, there's not many balls under these. They wouldn't be difficult to unsolder and reball. But I'm not convinced that is a worthwhile way to go. And the reason being that the customer has two of these. Detlef has the other one in actual fact. or had the other one. He says it's behaving exactly the same way as this one, which would make you think there's a common fault between the two, and it seems a bit unlikely that faulty BGA or bad soldering is the fault on both of them. Yeah, down there. So I did a little bit of research. I thought, well, hey, you know, let's go and Google how to, you know, repair SSD drive that's not detected. And I actually found quite a lot of videos telling me how to do that, but unfortunately none of them have gone as far into the process as I already have. Yeah, none have gone as far. I've gone further than any of those videos have already, and I still haven't got any closer to fixing this. There was one from Northridge Fix, similar sort of thing, but he had a short circuit capacitor on one of the voltage rails, and to be quite honest, credence to him for repairing that. But if I'd had a short circuit capacitor on one of the voltage rails, I would have fixed this by now. So I could say that's not a difficult fault to repair. Again, you guys comment. I tried to find out whether the controller on the SSD can write a kind of kill code to the EPROM, so it detects some sort of error, and it says, oh, I'm foobarred, and it writes something to the EPROM to say, you're foobarred, remember the next time you get switched on, and then it just reads that back and won't do anything. I have absolutely no idea, like a kill switch, but I don't know. Honestly, I don't know. And I had a look to see if I could find some way to analyse what's in that EPROM. And apparently I can, but it's specialised software hardware, which for the sake of the fact I've not been asked to fix one of these before, well, I'm not sure. And even then, that hardware and software is more aimed towards data recovery than actually fixing the thing. So I'm not sure it actually suits the purpose anyway. So I think there's enough reasons there to say I haven't fixed it and I'm not likely to. Yeah. But hey, repair community here. So what do you guys think? Anything else I should try on this one? Is there just a good reason why nobody seems to be repairing these things apart from, well, okay, Northridge did. Yeah. Or is the information and the knowledge out there, just nobody wants to share it? Okay. Questions? Do you have any answers? Well, you know where to reply, down there. I will put in the video description the link. I'll give you that EPROM dump. If anybody has any knowledge of this, you're welcome to have a look at it, see what you think. And I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.